Okay, this is our test review, so I will be working this. Remember to pause the video as needed. Number 1, Alicia is buying candy. She can choose any combination of jelly beans and lollipops, and she does not want to spend any more than $55. If jelly beans cost 1 cent each and lollipops cost 50 cents each, write an inequality that represents all possible combinations of X jelly beans and Y lollipops. Okay, so I know I want to write an inequality. And she doesn't want to spend more than. So she's wanting to spend less than or equal to $55. I also know that I'm just writing one inequality because it says write an inequality, not a system of inequalities. I know jelly beans are X, and I know lollipops are Y. I know jelly beans are 1 cent each, so I'll have 0.01X. And I know that lollipops are 50 cents each, so I'll have 0.50Y. So 0.01X plus 0.50Y is less than or equal to 55. The graphs of lines K1 and K2 are shown on the grid. What is the solution to the system of equations shown in the graph? Okay, so remember when we are graphing and I'm looking for a solution, my solution is where the two lines intersect. So in this case, I can easily see that my solution is 2 and 2. Number 3, solve each system of equations below. Okay, so I'm going to solve them using various methods so that you can see. But remember, you can use any method that you choose to use. But I'm going to choose the ones that I feel like are going to be the fastest for whatever that method is. Being that most of these are in standard form, I may feel that the best method is to use elimination. But on A, I'm going to go ahead and use substitution. I want to use substitution because I can easily add y on both sides. And then I can see that x equals 13 plus y, sorry. So if x equals 13 plus y, I'm going to plug this into my x. So I have 4 times 13 plus y plus 2y equals 10. Okay, 4 times 13, so I'm going to distribute this. Now I'm just solving my equation. Is 52 plus 4y plus 2y equals 10. 52 plus, now I'm combining my like terms, 6y equals 10. I'm going to subtract 52 from both sides. And I get negative 42. And then I'm going to divide by 6. And negative 42 divided by 6 is negative 7. So y is negative 7. Now that I know y, I'm going to go back. And I'm going to actually use this right here, even though I could use either one of these. Okay, but I'm going to, since I went ahead and solved for x here, it's easiest for me to plug into this space. So I'm going to take x equals 13 plus negative 7, because I know y equals negative 7. 13 plus negative 7 is 6, so x equals 6. So my solution is negative 7 and 6. Oh, sorry, I wrote that backwards. Hopefully you caught my mistake. I should write it as 6, negative 7. Okay, moving to B. Negative 7x plus 2y equals 18, and 6x plus 6y equals 0. So I'm going to use elimination on this method. I'm going to multiply my top equation by negative 3, because I want to get this right here, my 2, to be negative 6y. So I can add them together and eliminate them. Negative 3 times negative 7 is a positive 21x. And a negative 3 times a positive 2 is a negative 6y. And then I'll have negative 3 times 18 is, let's see, a negative 30 and a negative 24 is a negative 54. Okay, so now in elimination, remember we just add together. We're just combining them. So 6x and 21x makes 27x. And 6y and negative 6y combined together makes 0. And on my other side, I have negative 54. So now I'm just going to divide both sides by 27. So I have x equals negative 2. Okay, if x equals negative 2, now I can just solve for y. So I'm going to pick one of my equations. So I'm going to choose 6 times negative 2. So I'm plugging in my x value plus 6y equals 0. So negative 12 plus 6y equals 0. I'm going to add 12 to both sides. So 6y equals 12. And then I'll divide by 6. So y equals 2. So x is negative 2 and y is 2. So my solution is negative 2, 2. Okay, last. So being that, again, that both of these are in standard form and neither one of them is solved for y, I'm going to go ahead and use elimination again. So I can see this is negative 16, so I'm going to multiply the top by 2. So then I can have a positive 16x minus 12y equals negative 40. Don't forget to multiply all the way across. By doing this, now I can eliminate my x. I can see that this is negative 5y equals negative 10. Now I'll divide by negative 5. So y equals positive 2. All right, if y equals positive 2, now I can just choose either one of my equations and plug in and solve for x. So I'm going to use my first equation, 8x minus 6 times 2 equals negative 20. 8x minus 12 equals negative 20. I'm going to add 12 to both sides. When I add 12 to both sides, I have 8x equals negative 8. And I'm going to divide by 8. X equals negative 1. So now I have my solution. X is negative 1. Y is 2. So negative 1 and 2 is my solution. Okay, number 4, Mrs. Fraser is creating a test for her students. There are multiple choice questions and short answer questions. There are 3 times more short answer questions than multiple choice questions. There are a total of 28 questions on the test. Write a system of equations that could be used to determine the number of multiple choice questions, M, and the number of short answer questions, S, that are on the test. Okay, so I have multiple choice questions, M, and I have short answer questions, S. And I know I have a total of 28 questions. So if I add my multiple choice plus my short answer, I'll get 28. Okay. I also know that there are 3 times more short answer questions than multiple choice questions. So in other words, to find out how many multiple choice questions I have, I'm just going to take my short answer questions and multiply by 3. 3 times my short answers would give me my multiple choice. So that is my system. Okay, number 5. Graph 2x minus y is greater than 6 on the coordinate grid. So remember, to graph, we have to put in slope-intercept form. So that means I'm solving for y. I need it to look like y equals mx plus b. Oops, sorry, made a big jump. Okay. Okay, so I have 2x minus y is greater than 6. I'm going to solve for y by subtracting 2x from both sides. So I have negative y is greater than 6 minus 2x. And then I can't have a negative y. So I'm going to divide by negative 1. And I'll have y is greater than, oops, I should fix that. Y is less than, because I divided by a negative, negative 6 plus 2x. Okay, so when we are graphing, remember we have to graph my slope, or I have to graph my y-intercept first. So I'm going to graph negative 6. And then I'm going to use my slope. So b is negative 6. I'm going to use my slope of 2 to make my line. If I have a slope of 2, that means I have a slope of 2 over 1. So I'm going to go up 2 and over 1. And you can make as many points as you want, but really once you have 2 points, you have your line. So y is less than negative 6 plus 2x. Remember, I'm using this symbol now, less than. So I should know that I need to shade below the line. I also should know that my line is dotted. Okay. But I can always take a test point. So let's use 0, 0. I have 0 is less than negative 6 plus 2 times 0. So I'm plugging in my test point. Well, we know 2 times 0 is 0. So 0 is less than negative 6. Is this true? No, 0 is not less than negative 6. It's false. So since it's false, I don't want to shade where 0, 0 is. I need to shade on the opposite side. So my equation, or my inequality, I'm sorry, should be shaded below the line. Okay, so let's list 3 ordered pairs that are solutions to y is greater than or equal to 3/4 x minus 4. Okay, so remember, in inequalities, we have more than one solution. Y is greater than or equal to 3/4 x minus 4. I know my y-intercept is negative 4. I know my slope is 3/4. So I'm going to go up 3 and over 4. I know that it's greater than or equal to, so I'm going to have a solid line. Okay, now I just need to determine where to shade. So I know my greater than or equal means I need to shade above the line, but again, I'm going to grab a test point to prove that. So 0 is greater than or equal to 3/4 times 0 minus 4. Well, 3/4 times 0 is 0. So 0 is greater than negative 4. That's a true statement. 0 is greater than negative 4. So since it's true, I'm going to shade above my line. Okay, so now I'm going to list ordered pairs that are in here. So 3 ordered pairs that are solutions. It could be anything within the shaded region, but since my line is solid, it really could also be the lines, the points on the line. So I could have 0, 0, since we already used that as a test point. I could have 0 and -4, because that's on the line. But I also could have -5 and 7. It really is anything that's in here. So you could have anything different than me as long as it's within that shaded region. Number 7, write the system of equations, then determine whether each graph below has no solution, one solution, or infinite solutions. So let's look at the first. So first of all, I can tell it has one solution. I'm going to need to be able to find the solution. The second one I can tell is two solutions, or I'm sorry, infinite, because it's one line. It's the same line. And the last line, I can tell that it's parallel, so there is no solution. Because parallel lines have the same slope, so they'll never cross. But it wants me to write the systems. So I need to write an equation for each of these. Okay, so let's start with my green line here, my y-intercept. I don't know if this is exactly accurate. I think it's 8. It's kind of hard to tell. But we're going to use 8. Okay. And then connecting, it's going down 5 and over 7. Okay, so now I know that my y-intercept is 8. So y is equal to, because it's a system of equations, and my slope is -5 over 7 plus 8, my y-intercept. My next line has a y-intercept of 3. And it has a slope, if I go to the next point, of 1. And I know this isn't perfect to this graph, but you shouldn't ever have anything that's quite like this. So we're going to use this. Okay. So my slope is going up 1 and over 1. So my slope is going to be 1. So y equals x. Y-intercept of 3. So x plus 3. All right, going to my next graph. Hopefully you can tell that we only have one line, so that means that it's the same line. Most likely you would be given this in 2 different forms, so you'd have to change your form to slope-intercept form. But I can see my y-intercept is 3. And my slope is -1, 2, 3, -4 over 5. So I'll have -4/5 x plus 3. And really that would be written twice, but again, it would probably be in a different form. So it might be changed to standard form or something like that. My last one, I'm going to have 2 equations, and I'm not going to write both of them because this first graph's a little messy. But I can see that it's going up 2 and over 6. So my slope is y equals 1/3 x. And then I have some sort of y-intercept. It's really hard to tell what it is. And my second one, since they're parallel lines, it's the same slope. And my y-intercept is -7. So 1/3 x minus 7. Number 8, graph the system of equations below to find the solution. Okay, so I need to solve for y again. So 4x plus 2y equals negative 16, solving for y. I'm going to subtract 4x from both sides. 2y equals negative 16 minus 4x. Then I need to divide by 2. Y equals negative 8 minus 2x. Okay. Negative 8 is my y-intercept. And my slope is negative 2. So that means it's going down 2 and over 1. And I can continue that working backwards if it's going down 2 and over 1. Okay. The system of equations, so it'll be a solid line. And my next one again needs to be solved for y, but I just need to divide both sides by negative 8. So I'll have y equals negative 1/2 x minus 3. So my my y-intercept is negative 3. And my slope is negative 1/2. So it's going to go down 1 and over 2. Okay, so it's really hard sometimes when you're graphing yourself to know where you're intersecting. I think it's right here at negative 3, and I'm not really exactly sure. It's really close, okay? I could keep looking, but really I could look in my graphing calculator too and remember to find your intersection. But if it's a multiple choice test, you should be able to eliminate and find where it would intersect to find your solution. Number 9, cleaner carpets charges $75 to come to your house and $17 per room to clean your carpets. Like new carpet charges $55 to come to your house and $2 per room to clean your carpets. The table below shows the charge for each company. What is the number of rooms a customer would need to order from each company for the cost to be the same? Okay, so cleaner carpets is $17 per room. So they've already kind of started putting the table together for me. So if I continue, adding 17, this would be 126. And adding 17 again, this would be 143. Okay. And then looking at the other one, if I start to do that, I'd have 99 and it's $22 per room. So I'm going to add 22 to that. So 22 and 99 is 121. And then I'm going to add 22 again, which would be 143. And already I can see that this is my solution. This is where they would be the same. So 143. And number 10, write the system of inequalities that are shown in the graph below. Okay, so let's start with my blue line. So my blue line has a y-intercept of 4. And finding another slope, or finding another point, I can see it's going down 1 and over 1. So the slope is negative 1. So as an inequality, it's y, and I see it's shaded below the line. Since it's shaded below the line, I'm going to have y is less than negative x plus 4. Okay, looking at my red line, I have the same y-intercept, but my slope now is going up. Let's see, let's find some good points here. This one's hard to find points with that dotted line. Here's one. Okay, so it looks like it's going from 0 to 4 and negative 3. So let's see, it's going up 4 and over 3. So 4/3. And this one is shaded above the line. Since it's above the line, I should have a greater than symbol. So my equation is y is greater than 4/3 x plus 4. I need to make one edit. This one should be less than or equal to, since it was a solid line. And that can give you some really big keys on a test to eliminate some choices if we don't have the correct signs.